Hello everyone, welcome to my channel. Now in this video I am going to discuss the topic principle of superposition with regard to the electric field, and this video will be useful for students who are preparing for their JEE main examination as well as NEET and AIIMS. Okay. Now as we know that principle of superposition has wide applications starting from the chapter wave motion in class 11 to wave optics in class 12, then in electrostatics as well as in magnetism. So we are going to discuss in this video one concept of this principle of superposition with regard to electric field, and then we will see some application based on this concept. Okay. Suppose we have two charges placed along x-axis. So this is x equal to 0, this is x equal to plus a, and this is x equal to minus a. So this is your x-axis. So you have two charges, two identical charges placed at x-axis, on the x-axis. Okay, two identical charges plus q, both are positive charges. Okay, and this is the origin, and this is the perpendicular bisectors. This is some point P. Okay, and this point we have to find the field due to these two charges. Okay, now let us complete this triangle, and let's say this angle is theta, this angle is also theta, and the distance of P from this point O, it is say y. Okay, so electric field at P due to this charge. Now say, remember, these two charges are positive charges. So now we know that electric field intensity at a point due to a positive charge, it is always directed away from the charge. Okay, so electric field intensity at this point due to positive charge, it will be directed away from the charge. Similarly, electric field intensity at this point due to this positive charge is also directed away from the charge. Okay, being, if for a negative charge, electric field intensity will be directed towards the charge. For a positive charge, electric field intensity will be directed away from the charge. Okay, so that means electric field intensity at this point, it will be for this charge, say it is E1. Similarly, for this charge, it is say E2. Okay, now since this angle is theta, both are angle theta, so this angle will be theta, this angle is also theta. Now as you can see, E1 and E2, they will have same magnitude because the charges are same and the distances are also same. So we have E1 is equal to E2 is equal to 1 by 4 pi epsilon naught q, the charge, divided by this distance. This is a, this is y, so this is a square plus y square, square root of this. So this is a square plus y square. Okay, now we have the value of E1 and E2. Okay, now this angle is theta, this is E1. So if you resolve this E1, it will be E1 cos theta in this direction, vertically upward direction, and E1 sin theta in the horizontal direction. Similarly for E2, E2 cos theta will be in the vertically upward direction, and E2 sin theta will be in horizontal direction. So this E2 sin theta and E1 sin theta, they are in opposite direction, they are equal in magnitude and opposite in direction, so they will cancel out. So the resultant field will be due to the cos component. So we have the resultant field E is equal to twice E1 cos theta. It should be E1 cos, so the resultant field should be E1 cos theta plus E2 cos theta, but E1 and E2 are same, so I have written twice E1 cos theta. So this is E is equal to 2, E1 is 1 by 4 pi epsilon naught q by a square plus y square. Okay, how about cos theta? Cos theta is base by hypotenuse, so that is y divided by square root of a square plus y square. Okay, so this gives E is equal to 2 1 by 4 pi epsilon naught q by qy, this is a square plus y square 3 by 2. Okay, so this is the value of the resultant field. Okay, now since we have obtained the value of the resultant field, now see how this resultant field varies under certain special conditions. Now what are the special conditions? First, let us say this point of observation of electric field is far away from the system of two charges. This point of observation of electric field is far away, so that means this distance y is far greater than this a. Okay, so we have y very much greater than a. Now if this y is very much greater than a, so in this quantity a square plus y square, denominator we have a square plus y square, so this will be approximately equal to y square. So a square plus y square almost equal to y square. So this y square is to about 3 by 2, it will be y cube. So this E will be 1 by 4 pi epsilon naught 2q y divided by y cube. So this one y cancels out. So this becomes y square. Okay. So this is quite interesting. See, if suppose these are two fingers, okay, you are observing these these two fingers as two fingers, okay, but if you move very far away from me, you will observe that these two fingers are single finger, okay, they will appear to be single. Similarly, this two charges plus q and plus q, okay, when you are observing from a close point, you are seeing them as two different charges, but when this point of observation moves very far, these two charges appears as a single charge. So this q and q becomes 2q and you are at a distance y. So this is the expression for the resultant field. Okay. Now let us see another implication based on this result. Okay. That is, suppose you are asked at what location of P the intensity of electric field is maximum. Okay. So for that, for E is equal to E max dE by dy, it should be equal to 0. Okay. So if we that means this quantity should be equal to 0. So for dE by dy equal to 0, let us differentiate this. So this is 2q by 4 pi epsilon naught. This is a square plus y square 3 by 2. If you 2q is taken common, if you differentiate y, it is 1. So minus y, then this is into 3 by 2 a square plus y square 1 by 2, then y square is twice y divided by denominator square a square plus y square cube. So this quantity is 0. So this quantity need to be 0. So now this term, if I remove this term cannot be 0, and if I take this term over that side, so this will be a square plus y square 3 by 2 is equal to this 2 and 2 cancels out. So this is 3y square a square plus y square square root. Okay. So if I remove this term, this 3 by 2 goes. So we have a square plus y square is equal to 3y square, or 2y square is equal to a square, or y is equal to plus minus a by root 2. So at this distance, y is equal to plus minus a by root 2. The intensity of electric field will be maximum. What does it mean? Y equal to plus a by root 2 and minus a by root 2. That means a by root 2 distance above this point, a by root 2 distance below this point. At those two locations, you will have maximum electric field. Okay. So we have seen the electric field when the point of observation is very far away from the two charges. Now let's see what happens when the point of observation is very close to the two charges. That is, y is very much smaller than a. Okay. So y is very much smaller than a. In that case, this a square plus y square, this can be approximated to be a square. Okay. So now E will be 1 by 4 pi epsilon naught 2qy divided by, this will become a cube. Okay. So this is the value of the electric field if point of observation P is very close to the two charges. This y value is very small. In that case, this is the value of the electric field. Okay. Now suppose at this particular position, at this value of y, a negative charge minus q is placed. Now if at this location of y, if a negative charge is placed, it is going to experience an attractive force, isn't it? So what will be the force? Force will be 1 by 4 pi epsilon. Now let us cancel this 2. So this becomes q minus qy divided by twice pi epsilon naught a cube. Okay. So this is the force on the negative charge. Okay. Now as you can see, this satisfies the condition, that is F proportional to negative of displacement. That is the condition for simple harmonic motion. Okay. So that negative charge it will experience an attractive force due to these two charges, and it will start oscillating like this. Okay, it will oscillate like this. So let us calculate the period of oscillation. Okay, so now this is F is equal to minus QQY divided by twice by epsilon naught AQ. Okay, so this is equal to minus M omega square Y. Okay, for simple harmonic motion. So this minus minus cancels out, this YY cancels out. So omega, this gives omega as QQ by twice pi epsilon naught M AQ square root of this. Okay, now we know that omega is twice pi by T, where T is the period of oscillation. So this gives T is equal to twice pi square root of twice pi epsilon naught M A cube divided by Q cube. So this is the expression for the period of oscillation of the negative charge. Okay, so this is the video based on principle of superposition and the applications related to it, and I hope these concepts are clear to you and it will be beneficial for your examination. My best wishes to you. Good luck.